Hi guys, welcome to another LER Electronics repair video. I have something here, I've never looked at one of these before, and hopefully maybe you guys haven't either. So, this is a IWA horse. And it's well, it's a radio, it's a flashlight, it's a siren and generation electric power. So it says medium wave, 2 shortwave bands, FM, band switch, siren, power, it's on, tuning. And then on the end is a big knob. Let me zoom out. So there we have it, Amigo 5, and it has this thing on the end of it, and it's a generator. So this is like one of these like radio devices for after the apocalypse. So at least you can listen to the radio stations if any are still transmitting while the zombies are after you, that sort of thing. And as far as I can see, it doesn't work. So I've wound the end. Doesn't seem to turn on. Set it to siren, it doesn't make a siren go. Light, flash, on, off. Yeah, and that's what we have. I picked this up at the car boot sale at the weekend. He was being quite stroppy and wanted €15 for it, although I clearly told him it doesn't work. And I just thought it was such an interesting thing to play with, I just bought it off him so we could make a video with it. It's got a power, I don't know whether that's like a power in or a power out. I think the first thing we'll do is let me see if I can find a user manual for this and let's see what that tells us. Okay, well, it would seem that we're pretty much on our own with this one, because apart from seeing an odd picture of one that somebody described them as vintage new old stock, and they seem to be thinking they were worth $65. There's no real information other than that about it. I can't find anything about this. So the first thing I guess is we're going to have to figure out how to get in it, and then see if we can figure out if this is supposed to be an input or an output. If it's an input, let's try power it up. It says no batteries needed. That doesn't mean it might not have a rechargeable battery in it that may or may not work. So here's the big question first. How do we actually get into this thing? Well, I guess the answer to that is on this side, because there seem to be some screw holes down here. If I just shine my torch. Screws down here. Power supply DC 4.5 volt adapter, so it does work off a power pack. So we'll have a change of plan then. Get rid of the back. Let's connect our power supply to it and see if it works. I have my bench power supply. Let's just move this so you can see it. Yeah. Stop it falling over. Yeah, it's there. You can see that. So there's the power supply. Set to 4.6, which is good enough. I'll just make sure I have the polarity right on the lead. Yeah, I do. So we have a 4.6 volt supply, which I'm sure is close enough to what we want. Let's see. Just regulate the current a bit. What's it do? Well, it draws some power, but I don't hear any siren. The torch doesn't work. It doesn't seem to make any difference what I switch on or off. And the radio's not working. I'm assuming this has a speaker built in somewhere. Well, it says earphone, but I'm guessing if it's a siren, it's also got a speaker. Yeah, I can see a speaker inside it. So it doesn't. Oh, hang on. Have I switched it off? No, it doesn't do anything. But it does draw some power. So that's basically what we have. Now we need to open it up. Well, it's coming open. And it smells like something that's burnt in it. I smell a definite burning, like, you know, like something's been burning. I have to say in there. This is now kind of come loose and falling off. I haven't done anything to that. Some of the screws are proving very difficult to actually get out. I only have 2 of them out so far, so I'll just have to carry on until I get the rest of them out. Okay, I'm inside it. Some broken bits of plastic. This was kind of jammed on. This is the ring that fits on the front around the torch part. That was what was kind of holding it together in the end. I'm guessing those bits of broken plastic were what was rattling around inside it to start off with. So I don't think that's me. So I wouldn't say it smells of burning, but there's a funny smell in here, like an electrical smell. That's the only way I can describe it. So that's what we have. We do have a battery, and it's down here. So that's my first thoughts with this. I'll just get rid of the little glass as well. My first thought is that the battery's failed, basically. While we're at it, we can just test the bulb because the light wasn't working. Let's see if the bulb's good. Put the test meter in here. Okay. If you can see that. Yeah, so you can see it now. So we've just gone to resistance range. And let's just check the bulb. Yes, the bulb's okay. But the bulb doesn't light up. So my first thought is that there's a problem with this battery. That seemed like the most likely thing. So we need to see if we can get this out. There's obviously a screw which kind of like holds it in place like so. A bit of Heath Robinson this thing by the looks of it. And then I'm guessing this actually, one way or another, I don't even know what that is. It's just like wedged in there, yeah. And then it's like, oh right, it's kind of like stuck in here with some old glue. It's coming. I think we've got it. There we go. There's the battery pack. So it looks like we can find, some rechargeable batteries for this. Let's have a look on the test meter and see what the battery is like. So if we just hold this in, it should go back to auto, then one touch. Yeah, better it keeps press to get anywhere. So this is our battery. I'll just go across the battery. Well, you can't do. Oh, I'm reading with the leads the wrong way around. Sorry. So it reads practically 0. Yeah, a little bit of voltage, 0.2 of a volt, something like that. So that's the first thought, is that the battery is duff. But that doesn't really kind of explain why I got nothing out of this when I had it on the power supply. Yeah, this battery, it's reading like 0 volts and everything. I connect it to my power supply. So I set the power supply to 4.6. This is the end where the positive one was, about the green on it, yeah. This is where the negative wire was. So if you get out to the power supply, okay, you can see that it just goes into current limit. I've set the current to be very low at the moment on the power supply, but it's reading like it's practically a short. So if I give it a little bit more current, even up to an amp or so, this is hardly moving. So my first thoughts are actually this battery is completely no good. So I think if I just get like 3 AA size rechargeable batteries and wind them up, that should probably do the job. Let's just get the plastic sleeving off this and let's see if there's any markings at all on the original ones once we remove the plastic effectively cover from it. Let's have a look. They're probably just white, but we can see. Yeah, there's nothing marked on these to give us an idea. So I'm pretty sure that my best guess is I'm just going to get some rechargeable AA size batteries and stick them in it and see what happens. I've connected the bench power supply in place of the battery then. So let's see what it does now. Well, it's working, but I don't know if you can see there, no matter what I do with the volume control, it doesn't. It's like on full volume, I think, all the time. Oh, that's fun, isn't it? The siren works. How about the torch? Is this working? Yes! On. Well, you go to. Oh, it does flash. Yeah, it goes flash, it goes on. So that's all working. So it seems that probably if I put some rechargeable batteries in here, it might well work. Also, the power supply, now if you notice when I switch it on, it's only delivering about 100 milliamps, not like 1.5 amps. I'm guessing that power was all going into the batteries, which were effectively short. I wonder if that's what was making like a sort of a burnt smell in here. I think the next thing to check is we'll see if we can power it from here. I'm pretty sure we can power it from there. And then let's have a look to see why this volume control isn't working. I mean, it looks like, if you can see it, it looks like part of it's broken off there, but I don't think that's the case because there's no hole in the circuit board. Oh, hold on. Yeah, this bit must be the switch, and then the connections underneath are obviously for the variable resistor. And I suspect that there's probably a fault in this itself, which is why I can't change the volume. But let's have a look. We'll just check the 4.5 volt input first. So we'll plug this into the power supply. Yeah, and again it's working. I just can't alter the volume with the volume control. So let's see if we can get this PCB out of here and then work out what the problem is. I've taken all the knobs off. I just noticed these rather attractive pink screws he put in here, just out of interest. Just yeah, that's a different touch, isn't it? Pink screws, yeah. How bizarre. I'm not sure what that's all about, why you would have pink screws. Maybe you got like a job lot of pink screws from somewhere cheap as nobody else wanted or something. I wouldn't have thought they'd paid extra for them, would you? So we'll remove these pink screws. I mean, don't get me wrong, there's nothing, you know, there's nothing wrong with this pink screws per se. It just seems a little bit, well, odd. That's the best description. Pink screws under here somewhere. It's loose. It's out. It's out. Oh, it'll come. So we need to. Yeah, that gets out of here. Now let's see if we can just get a cable tie off here. Maybe I've got a little bit more room to work on this. Okay. So there we go. Yeah, it's kind of released that a little bit. I'm going to take this one off as well. So we can stretch it all out a little bit there. There you go. Maybe see a little bit better what's going on there. Okay. There we have it. And then there's one which is attached down here to the socket. So we remove that as well. Then we should be able to. Yeah. Right. Okay. We have the PCB. So this is our volume control, the potentiometer, variable resistor. It's going quick, that's the one with the on off switch. I have the power disconnected in the middle because it's just too noisy. You would assume that one end of the potentiometer is probably connecting to ground, which might be the grey wire which goes to the battery. Let's have a look. See if any of the pins go to here. Well, that goes there kind of through resistance. Okay, neither of them do. Okay. Because what I'm thinking is you effectively got like audio coming in on one end, ground on the other end, and then the slider can effectively move between the two. Let's see if the potentiometer actually works. I'm guessing it is making a contact to the track because I have some sound. So we can measure from here to here. At the moment it's in the off position. So we can measure from the middle to one end, and we have about 9k. And this is expected to be 0 or close to it. No. You'd expect that at one end of the track, the centre would connect to one end of this. Yeah, it goes to that end, that's connecting to there. Okay? But what's not happening? I'm going just before the click. It's not connecting to here. So it's like there's a broken connection from this end of the track to the potentiometer, and that would stop the volume from turning down. I'll just draw it on a little bit of paper and you'll see it quite clearly. So this vintage device, and probably on a lot of cheap devices, this is where effectively the variable resistor was in the audio path, as opposed to more modern devices where effectively you have a voltage controlled amplifier. So the variable resistor, if you have one, you'll probably have touch buttons, is not in the audio path. It's just effectively having an amplifier in and out, and the control voltage. So the control voltage on here will set the output, the level of the output. This is much more primitive. So here you're going to have effectively a variable resistor, and this end is going to have the audio signal on, and this end is going to go to ground, and then you'll have a slider here, and this will go into the amplifier circuit, probably into a transistor, and so on into the amplifier. And what's happening is, when we move the slider to the highest volume, which effectively would be here, so the signal's coming directly through, we see from here, the slider, to here, on our test meter, we can see that we've got 0 ohms, yeah? 0 or 0 ohms. But when we go from here to here, on our test meter, we have like no connection. So from that we can say two things, yeah. One is that the slider is making contact with the track, because as we move it, the resistance from here to here changes. And two, most likely the track inside the potentiometer is not making a contact here. So I'll have to unsolder the potentiometer and have a look. But now I've shown you this little diagram, I'll just show you again that we have a break somewhere here. I probably need 3 hands to do this, but lacking one limb, I can't do that. So if we go from this is the wiper on the diagram, this is the end that's connected effectively to where the music's coming in. So if we go across here and I move the slider on here, we see we now have about 10k, and I keep moving it onwards. As I move it towards this end, so it reaches the end of the travel, there, 2 ohms, yeah. As I move it the other way, that increases. I'm in the hundreds of ohms, I'm in the kilo ohms. As I keep going across to this end, yeah, it's about 5k, I'm not sure what value the thing is. So this slider is obviously making a contact to this end, but if we go to the other end, here, you'll see as I turn this down, we should now have a connection here. And we don't have, we've still got a kilo ohm or more, yeah, 103 kilo ohms, sorry. And as I turn the knob the other way, you'll see actually that resistance is going down to about 7k. So the slider's moving to this end, and the resistance should be going up between these two. The reason it's going down is effectively this is open circuit. So I'm actually measuring through the slider back out into the circuit and some way back around to here. That's why I get a lower resistance at this end, which is obviously wrong. So what we'll do is we'll take this off, this potentiometer, and we'll have a look to see if it actually is faulty and see if we can actually fix it. The switch is actually on the back of the potentiometer, and there's looks like a very low value resistor and a piece of wire link in there. So we need to take those off as well to get to this. It might be easier to just unsolder the other ends of those as you go into the board. But let's have one. Let's just see if we can actually unsolder them where they go to the potentiometer. Let's have a look. So we'll get on here first. I'll have to add some fresh solder. I'll probably have to add a bit of flux as well, to be honest. Let's see. Okay, that's got some fresh solder on there. That's just my multimeter going to sleep. It looks like these are actually sort of stuck through the holes in the pins, basically, so they're not going to come off so easily. Let's have a look. Okay. Let's see if I can actually get them off here. Need some tweezers. It's a little bit fiddly down here. There's a few wires and capacitor in the way. I can move it all out the way a little bit and then see whether we can actually easily just lift this from here. Yeah, that one's away. Do the other one as well. Obviously doing that left-handed, keeping the right one on the. There we go. Right one for the soldering line. Okay, so I've managed to lift the two legs there and there. Now we can unsolder the 3 pins on the potentiometer. These old circuit boards are not very nice to work on, to be honest. The tracks tend to come off quite easily. I'm going to use the desoldering tool, I think, and even then it's quite likely some of the pads will just lift up, but we can try it. It's like the copper isn't bonded very well to the board. Okay, let's see. So, have to clean the solder sucker out. There we go. Let's see if we can get this off. I mean, otherwise you can use a desoldering braid, but I find this does it best. I mean, the solder sucker you might use for this as well. Little handheld ones with a little spring clip on, but I find it usually knocks the pads off the board. I find this is the far better way. Yeah. So that looks like it's desoldered, but it might be. Oh yeah, there's obviously the nut on the end of it. So I think if we take that nut off, we should be able to get this off. If we can get to it. Obviously glued down quite well. Not glued well enough, not to stop me anyway. Find some more on those pliers. See if that will help us. Yep, it's coming. A bit fiddly, but it is coming. I think there's a bit of like glue in the thread, which is making it hard to actually get this off here. Still quite a bit of tension there. It's not turning freely, so I doubt I do it with my fingers. Yeah, I've got the fingers now. There we go. So we take that off, and then this should, with a bit of luck, just come off the board. Yeah, there it is. So there's our potentiometer with a switch on the back. We can just give this a bit of a clean when we're at it. Ready for replacing. So I'm thinking here there's like 3 little studs, if you like, and I'm suspecting one of these little studs isn't making contact onto the track, the carbon track. Let's have a look again. Let's see if this actually works. I'll use some crocodile clippers to make it easy. I have the meter on resistance range then. So let's have a look what we get. This is now turned effectively to this end. This is the off end, okay. And you can see it's reading into the mega ohms. I don't have a good connection here. If we go to the other end across the 2 ends, we should just read the resistance of the potentiometer, about 10k. If we go to this one, and we turn it this way, yeah, you see it's gone to 0. We turn it a little bit back, in the hundreds of ohms and so on, yeah. So that's where the problem appears to be. I'm sure the slide is making contact even at this end because I still read the resistance to here of 10k. The problem is, as I suspected, from this pin, I mean I've got 47 ohms now, so I've got a connection. But just touch this and it's going, yeah. So we need to take this apart and have a look to see if we can fix it. Usually you can get these apart by bending these little tabs outwards and then taking the thing off. Now this has a switch on the back of it which might make it a little bit more difficult. There's also tabs here as well, and it looks like if I bend these back I might be able to get the front piece off, but I'm not totally sure I can do that because there's shaft running through it. So I think I will initially try to take the back off. This is not too difficult to do normally, but of course now I'm on camera it's bound to be very difficult. So that's always the case. Anything that's normally a simple job, as soon as you stick a camera in front of it, it becomes a difficult one, or one to make yourself look stupid with, yeah. Whichever. So let's push these little tabs back and let's have a look what's inside this. Yes, the back bit's coming loose. I normally then use a pair of these. These are like old ones that are worn out. I wouldn't do this with the good ones I use for clipping wires, but an old pair of these snips has come out handy. If you got, I mean, they do eventually wear out, and instead of throwing them away, I relegate them for this sort of work. So let's have a look. So there's all the tabs straightened up. Then this comes off the back. Now we can see, I'm guessing this is part of the switch. And we can see down inside here. Yeah, the thing just doesn't click on and off anymore, so I'm taking the switch off basically. Now I need to get the front off. Maybe I should have actually left this back piece on there, but never mind, we can see what was inside it and we can have a go at putting it back together. So let's do a similar thing with these and bend the little metal tabs again and see if we can get the front off of this one. So that's one of them. I have the other one, yeah. You see the bending. A bit of glue or something on this, but it shouldn't really stop me. Okay. And let's move this bit of glue off here. We should be able to get to the other one. It's underneath here. Okay, I think I can get to it. Yeah, I've got to it. So again, we'll do the same thing. So we'll use these old edge cutters to just straighten the things up. One, well, it's coming off anyway. It's off, you know, with a bit of glue. So that's off as well. And putting it back together is just the reverse operation. So this was the way it was turning to go down. So I'm pretty sure this is the end that doesn't have a connection on the track. So you can see now inside it's like a little wiper which is sliding on a carbon track, like a horseshoe shaped thing. And I think what we'll find is that we've got no connection from here to one end of the track. Let's have a close look under the microscope. So here's our potentiometer. And you can see now how the slider effectively goes across the carbon track. this brown part here effectively is conductive. Looks like it isn't, but it is. So if we go with the crocodile clip leader here, you'll see that this actually is reading like 0 ohms up to here somewhere. And then this is where the carbon track starts, and this is where it looked like we had an open circuit on one end. Well, that seems okay. So you can see I'm going from here onto where the carbon starts about here, yeah? Let's have a look at the other end. So we're from here. So this effectively has a shorter one, yeah, you can see it. So again, we're going from here, 0 ohms. Let's just go to the start of the carbon track. Yeah, it looks like we have a connection now. It looks like taking this apart actually fixed it. What you sometimes have to do is take silver conductive paint. You can buy a little tube of silver conductive paint. And you have to put a little bit of conductive paint between the end of the carbon track and the start of this. And that makes a connection. You can't solder it, but conductive paint will do it. If I have some, I'll put a little bit on this one just to make sure it keeps the connection, yeah? But you can see we've got a connection from here as far as here. It's about 10k, yeah? And across here. So we definitely have a connection now, whereas we didn't have previously. Let me see if we've got any silver paint left. I had some of this, but I can't find it. I'll have to get some more. So this is basically the stuff I had. Silver conductive paint. And you can put a little bit, as I say, just where the carbon track reaches the end part. And that will fix it. But this one seems to be working. So let's put it back together. I'll just give it a quick clean with a bit of ISO. And after we've reassembled it, let's see if it actually now works. I've put it all back together again. You can hear the switch is switching. And we can just test that anyway. So I have my crocodile clip leads. Let's have a look to see what we have. So we have this one and this one. So this should be the switch. Yeah, that's working. Then if we go from one end to the middle, we should now see, yeah, it's at the low resistance end, and if I move, the resistance goes up. Come back to it, it goes down. Yeah, that's fine. Okay, and then this is the end that wasn't working, the one nearest the off position. So we go on to here, and now you can see it does work. Yeah. So that's working now. Whether it'll keep on working, I'm not sure. If I had some silver paint, I would have repaired it, as I said. Well, maybe it was just a bit of dirt on there or something like that causing the problem. Well, it was a bit hard to imagine how that would be, to be honest, because the fault didn't seem to be on the slider. Let's put this back together and let's see if it works now. So I'll need to solder the two wires back to the switch and just put the nut and the washer back on and solder it in. So it should not be too difficult a thing to do. Let's just tighten this up as best we can. I'll probably have to use the pliers, but let's see. It's going okay at the moment. Okay, it's tightened down anyway. We can just give it a little bit more with the long nose pliers. Here we go. Just a little bit of an extra tighten into position. There it is. Okay, so now we need to just solder these two things onto the back of it, and then obviously the three legs that go through the board. So we'll try and do the switch first. If I just get it to sit onto the terminal. Yep, that one's on. That one's on. Just, yeah, definitely on. And then we have the three pins that come through. And then let's see if the volume's actually working now. Okay, there we go. I'll connect up my power supply again. On, no horrible noise. Yeah, that's working now. Just try.
es ayuda a la economía. Este domingo.
Okay, so we're working. So there we have it. Working. Can't resist that.
Curro tremendo, vamos. Sí. A veces no entro por el portal normal,
Okay.
entro por las leches.
I wonder if they're on the shortwave bands here. Nope. Maybe not receive them on the workshop. And we don't. Medium wave doesn't receive anything here. We've tried it before. So that's that done. We got a problem with the antenna, which is basically broken loose here. But I'm pretty sure that I can just fix with some hot melt glue. So we'll fix that. And the other thing is whether the charger is working. Obviously this needs some new batteries, but out of interest, let's see if we connect our voltmeter to the wires. If I crank the charging handle, I should be able to see this charging up. I'm pretty sure. That seems reasonable anyway, so let's have a look at what happens. So we'll go on the black, grey rather, that's the negative. And we'll go to the positive. Let's put the voltmeter where we can see it. Okay. Just arrange that. One moment. Okay, so we're on volts DC range. I have the wires attached. What happens when we try to charge this up? Nothing appears to happen when we try to charge this up. Oh, okay. I thought we might see something there. I don't know whether that's because you need to have a battery for the circuit to work. But we can have a look. So we have a black and a red wire coming from the motor thing that kind of like disappear up into this part of the circuit. So let's see if we can see anything. I don't suppose it's generating an AC signal. That doesn't make sense with a DC battery, I wouldn't have thought. Let's have a look. So we'll take the little cable tie off. Makes it a bit easier to follow the wires. So we have coming from the dynamo or alternator charger, we have a black wire, we have a red wire. Yeah, that's these two, which go up onto here somewhere. Let's have a look. Again, there's a little bit of something tied on here just to make it difficult to see which wire was going where. I may have to just cut that off. There we go. Okay. Oh, well, there's a wire fell off here. Where's that go to? Well, that's one of the power coming in, and that's just like fell off. So we need to figure out where that went. Okay, and then what else have we got? That's one of the battery wires, and that has just fell off from somewhere. Did it come from here? It looks like it was only just effectively hanging on there until I cut that off and then it fell off. I see two diodes down here. So I suspect this is generating AC. Where's that going to? So we have a black one, yeah, which is this black one here, and we have a red one, which is this red one here. I wonder if this effectively goes to there as well. Let's have a look. Let's connect our meter across here and see if we see any voltage coming out of the charger. And it may be actually, the reason I didn't say anything before is because this wire had fell off. Let's have a look. So we have this one here, and we have the other one. This one here. I'll just check if I've got a connection. If I go to resistance range, yeah, I can see a low resistance there, so I definitely have a connection. Right, we're 1 volts. What happens? Oh, yeah, okay. We see a voltage, negative. Although I have the meter on the right way round. What if we go to AC? Do we see anything there? There is some AC component to it, but we mostly have a DC voltage coming out of this. I can see where the battery wires come off from. It comes from this little post here. I actually had a quick look back at my own video to see, but it's from here. So these are wire wrapping posts. They seem to be popular in the early 80s. I don't know why, because it was never that good to me, but it was a way of doing things rather than just taking a bit of solder. Using stiff wires and wrap them around these little pillars. So we can solder our wire back on there using some 2020s technology rather than some 1980s technology. The old technology is best, yeah. So we can just bend this little thing around a little bit and stick it on this post. And then have a look again to see if we can see any voltage on this post when we crank the handle. So that can go on there. Solder it on. If you've not worked on this sort of older stuff before, you'll probably find you're learning a few different techniques here, yeah. So that's on there. So we can put the meter onto volts again. Just power it back on. It had gone to sleep. And we're on the volts DC range. And then let's go from this pillar here with the red probe. I'll put the black probe on this pillar here, which is coming from the little voltage, from the little generator. That goes on there. Now let's see what we get when we wind the handle. Well, we don't get anything there, so it's obviously going through some sort of circuit here. Obviously some sort of circuit, but we do know we get something as far as here. Yeah. Although, as I say, the polarity is the opposite way around than I would have expected it to be. I think probably the best thing here is going to be to replace the battery first. I'll get some rechargeable batteries. And then let's have a look to see if we get any voltage now on this lead. Otherwise, I'll have to look at a circuit. I mean, it's possible because of the problem with the battery, if actually short and drawing a lot of power, we might have damaged some transistor in this part of the circuit. But let's do the obvious first and let's find some batteries, rechargeable ones. Okay, so we have it working. We can tune in some radio station on here. So it's working. And what I've done is I have the power supply actually connecting to the leads which normally go to the battery, like so. 4.5 volts. I have the voltmeter connecting to the terminals as well. So I don't have any batteries to test the charging circuit, but what I can do is see what happens on the voltmeter when I wind the handle. If we get more voltage there, then the charger, as far as I can see, is working. So let's give it a go. Yeah, you turn it that way. Yeah, it's generating voltage to the battery terminals. So I can only assume that the charging circuit is actually functioning. So all that remains to do now is to fix the aerial, which we'll use some hot melt glue, and put it back together. There we have it then. So it's working, it's charging, the siren's working, the bulb's working, the radio's working. It's just a matter of putting some batteries. And there's quite a bit of space down in here, so I think I can get like a little triple battery holder and put some rechargeable batteries in it. I'll just show you the sort of thing I have in mind. One moment. I've ordered a couple of these, so these are the three-way battery holders. I'm sure there's enough space down there to fit them. These are the AA size, which seem to be the same size as the original batteries. So I can get 3 rechargeable batteries and put them in here, and there'll be enough space to fit them down there. So I think really we can say everything on this is now repaired. Okay guys, I hope you enjoyed that one. I will just put this on one side now, waiting some batteries. Hopefully it'll turn up before the apocalypse happens, and when it does, well, this could come in useful, you know. I mean, just as an aside, if you can go and Google this, actually, if you like, and look up for the best places in the world to survive the collapse of civilization, yeah. And one of the top 10 is the Canary Islands, on the basis that we have a very equitable climate. They can exist, you can live outdoors here all year round without suffering any health problems. We have a lot of natural spring water, and yet it doesn't rain in the south. We're surrounded by ocean, and we have very fertile soil and a lot of other things. And the other main reason, we have absolutely no strategic importance to anybody. Yeah. So I'll keep this on one side. You never know when I might need it. I'm interested to hear what you guys say below, yeah. And if it's zombies, we're a little island, it's easy to keep them off here. Okay, I'll leave you with that thought, guys, and I'll see you all soon, if we're all still here, on another Learn Electronics Repair video. Ciao for now, guys.